numbers do we want to see? Do go over, have questions about. 1, 3, 2, 1, 2, 1, 2, 3. What number is that? Is that 1?
What are you doing?
Oh, 1 and 3 and 2. Okay. I was like, what? Okay, 1 and 2 and 3 are the ones I'm seeing a lot. 1 and 2 go together, so that works, and it can be done on Desmos. 3 can also be done on Desmos. 4 can also be done on Desmos, so we'll do all 4 of those. Okay, so first, to make your line of best fit, you're going to add in a table, put in your order pair, in your points on the table, and then in the next line, type in y1 tilde, the squiggly line, mx1 plus b. And this would be your equation for number 1. So y equals, you can round it or put all the decimals, 0.9, 0.89, x minus 0.08 or 0.09 as you're rounding, or 0.1, negative 0.1. Any of those would be fine. Questions on 1? So those are steps you have to remember. How do I do this in Desmos? How do I make the table? How do I get the equation? And usually it'll tell you what to round to, or it'll be multiple choice and you choose. Number 2, it says using number 1, find the milk consumption in a 1 week of a 7-member family. I cannot see today. So if x equals 7, find where those two intersect. And 6.15 or 6.2 gallons would be what that equals. Make sure you include the label gallons, 6.2 gallons. If you're rounding, or if you want to put the exact, you can put that, would you? Y equals, you can either use these in higher decimals or round 0.89, 0.9, x minus 0.1, 0.08, 0.09, round to 1, 2, or non. Questions on 1 or 2? Three, if they charge $15 per hour, so the per tells you it's going to be multiplied to something, plus a one-time fee to use the dumpster of $60, you're adding 60 to it. You're looking for how many hours of service were required if the final bill was 195, so that's what it equals. So you could set up this equation, 15x plus 60 equals 195. Put that in Desmos. And get an x value of 9. So 9 hours should have been your answer for that one. So all of your word problems can be done in Desmos as long as you know how to set it up. Questions on that one? And then this is actually good. So I was going to start off typing the next one, y equals mx plus b, to get the sliders. But it didn't give me the option to give the sliders because I'm already using those kind of in this table. So if you're on Desmos and that happens to you, you either need to get rid of your previous stuff or make a new, like close it and open up a new thing. So what should happen is the sliders got opened. This is parallel to the given equation, so I put in the equation, put in the order pair, and I'm looking at the original to see what my slope is. looks like it's up 1, right 2. So I can change my slope value to 1/2 since it has to be the same. And then I just move this until it went through that point, which happened to be at 2. So that would have been your equation for number 4. Y equals 1/2 x plus 2. Questions on 4? Five is one you'd have to do by hand because it's solving for x and not y, so you're not looking for slope, and you're looking for what that equation would be. So just make sure you're aware of that. Other shark bite questions before we move on to our lesson for today? We are almost done with all of our lessons. So we have what we're doing today, what we're doing on Wednesday, and that's the end of quadratics, so end of Unit 11, and then Unit 12 only has one lesson, and that's Friday. So after this week, we won't be learning any more new things. We'll just be reviewing and SOL reviewing and all those things. Okay. Everyone, yes?
Will we take a test on it?
After the SOL, but yes.
Okay.
We'll have review days and things like that, and we'll talk about that closer to that. So everyone should have these notes in front of them. Last class we talked about quadratics and what they look like and how to graph them. Today we're going to talk about how one way, there are multiple, we're only going to talk about one. One way to solve quadratics to get the zeros. And then how we find those on the graph. Right? So this connects back to our factoring things that we were doing. So if you don't remember those, I'm going to take out those notes, but we're going to talk about one of each type of factoring and how we solve that. So first things first is the equation has to be equal to 0. Whether that's on the right or left doesn't matter. Concatenate, it kind of matters, but not at the same time, but we'll talk about that later. So make sure the equation is equal to 0. If it's not, you have to get it there. Factor whichever side is factorable. And then once you find your factors, we're going to set both factors equal to 0 and so on. And that will give you your zeros or solutions or examples. So first, if we have something where there's a 1 in front, anyone remember how we factor this? Or what the rules are? It's a trinomial. There's a 1 in front. So this is one where you're looking for what multiplies to be C and what adds to be B. So find two numbers that multiply to be 3 but add to be 4.
3, 4. 1 and 3. 3 and 4.
Okay. When you have a trinomial where 1 is in the front, you can immediately go into your factors, whatever the variable is, and then if these are positive, which they both are, put plus 3 and x plus 1. So we factored it. Now we're going to take each factor and set it equal to 0 without the parentheses. And solve both of the equations. What's nice about when you have a factor that's just x plus something or x minus something, whatever the answer is usually the opposite. So this is going to give us -3 and -1. And when we write our solutions, they're going to be in curly brackets, least degrees. that would be it. That would be our answer. What questions do we have on that? Bless you. We're going to move on to another type of example, and then we'll go back and do any others you wanted to see. 10 has two terms, so not your trinomial rules. Anything with two terms, you can only use difference of squares or look for a GCF. Can we use difference of squares here? Are these both perfect squares? No. Can we factor out a GCF? Yes. What would that be? 3x. 3x. And what would be left?
X plus 1.
So we have now factored this. Now we're going to take each factor and set it equal to 0. So the 3x counts as a factor, and the x plus 5 counts as a factor. What's nice about your GCFs is that anytime you factor out something with an x, that will always be 0. No matter what. So then we'll have negative 5 and 0 as our factors. What questions do we have on that? Before we go on to the next page, look at 2 through 9. Are there any of those we want to see do go over? 6. So what's the rule for this one? Multiply to 20, add to 1, negative 1. So multiply to be negative 20, but add or subtract to be negative 1. Find two numbers that would work.
Negative 5 and 4.
Negative 5 and positive 4. So then we could put those directly into our factors, x minus 5, x plus 4. Don't forget your equal 0. Set each factor equal to 0. Once you've done this enough, if you know whatever I solve for is just going to be the opposite, you don't have to show the work for this. But when we have more complex factors, you will need to show the work for it. What would our two solutions be?
Negative 4 and 5.
Negative 4, positive 5. Any other questions on this page? If not, go on to the next. We're going to do 13. Right. Again, this has two terms, so difference of squares or GCF. Which of the two could we do? Difference of squares. Anyone remember how to factor using difference of squares?
X plus 8 and x minus 8.
So anytime you do your difference of squares, whatever the variable is, split that. Whatever the number is, take the square root of that, put a plus and minus in between them. Set each factor equal to 0. Correct. And in this case, if you want to write it like this, instead of separating it, you can. So either or. Okay. Before we do the next section, are there any others, 11 through 16, you want to see, do go over, have questions about? If not, let's jump down to 20. So what's different about this one? Are you raising your hand?
Oh, there's not a 0.
So that means we have to solve it. How you choose to do that is really up to you. I would say if you can, try to make the x squared positive, because that'll help you a bit. So wherever it's positive or would make it positive, move everything to that side. So I would subtract 4x over and subtract 1 over. And then it becomes a regular problem. So what two numbers multiply to be 48, positive 48, but add or subtract to be negative 14? If they're both negative. So then set both equal to 0. What would your zeros be? Both positive. What questions do we have so far? And are there any in that 17 through 24 we want to see you go over? Have questions about? Okay, on to the next page, if not. Now our last type of factoring is when a doesn't equal 1. Anyone remember the rule on how we start this? Okay. Does it have one?
Yes.
What is that? I think it's not the one I wanted to do. So we'll start this, but then won't continue it. What would be left?
x2 plus 3x minus 4.
Actually, we'll do 2 of these because I have to show you something else with this. So then you're just focused on the inside 2 numbers that multiply to be negative 4 but add to be 3. What were you going to say? Yeah, that wouldn't work for the 3, but it would give us the negative. Not to multiply. One of them would have to be negative. Regina? Negative 1 and positive 4. That would work. So keep bringing down the 3 on the outside. When you get something like this, you can't set 3 equal to 0 because they don't equal. So that just, you ignore that part. Unless it has a variable, that's the only time you set whatever's out here equal to 0. What would your solutions or zeros be? That works. So then example 3. if we're doing the same process, does that one have a GCF? So then what would be our next step? So not the entire thing, but just the 2 and the 5 and the negative 5. So we're looking for two numbers that multiply to be negative 10, but add to be 3. What two numbers would work?
5.
Yes. But because this one had a number in front, this one we don't just replace, we rewrite it. If you wrote yours the opposite, that's fine. What's our next step from here? Split it down the middle. And what do we do after we split it down the middle? So we're looking at the first two, and you're saying the GCF is 2? Okay. So look for the GCF of the first two, and it's 2x. What would be left? I'm sorry. If it was switched, if these two were switched, it would be 2x. It's just x. Great. So then what would be left? What could we divide out of the last two? Negative 1 is the only thing. And that would leave us with? So then our two factors would be 2x plus 5 and x minus 1. Set both of those equal to 0. So this one, the x minus 1, you don't need to show the work for this, but this one you do. So then what would your 2 zeros be? Are there any others on this page you want to see, do, go over, have questions about? If not, go on to the next. We're going to do 14 and then move on. Any others you guys want to do and then move on. So what would be our first step in this? Yes, by moving things to the other side. I would say move the x squared and the 2 to the left. So that way your x squared term stays positive. But when you move the 2 over, it doesn't have anything to combine it with, so you're really just subtracting 2. What's our next step? multiply 4, negative 2, and then what Virginia was saying, what multiplies to be negative 8 and adds to be 7. Which is what? Sorry. Oh, sorry. Is this something? It's okay. That doesn't work. Order which you put it in doesn't matter. Next step. Put it. You guys can say this out loud. What did you say on this side be? 4x. What would be left? X plus, I didn't do the last part. Not 1. Not 1. 2. There we go. And then GCF on the other side? Negative 1. Which would make the inside so then our two answers, or our two factors, we have 4x minus 1 and x plus 2. If somehow, if this were a special type of function where you got 4x squared minus 1, you would need to factor this again. And then after you factor that again, you would set it equal to 0. So you would have a bunch of solutions. It's not the case in this one, but keep that in mind. Set each one equal to 0. Actually solve this one. What are the two zeros?
Negative 2 would be
Do we have any questions on how to solve by factoring to find our zeros? And are there any others on this page you want to see go over? If not, go on to the next page. So that was one of the methods of solving algebraically. This would be finding it on a graph. I don't remember what this is. I'm going to let you guys write this part down and draw this in. So roots, we talked about that as being another way you describe zeros or solutions. So the points at which the parabola, the U shape, intersects the x-axis. Intersects or crosses or touches, so you can put any of those. And then they're also called these three things: zeros, solutions, x-intercepts. So all of those are interchangeable. Then there are three types of solutions. 2, where it crosses or touches twice. 1, where the parabola only touches the x-axis once. Or none, it doesn't touch it at all. Once you have that written down, go ahead and put number 1 in your y equals on your calculator. And we're going to go into the table, second graph. And we're going to find where y values repeat. Do you see any repeating? Your table could be different than mine, depending on who the last person had it. Do you see repeating y values? If you do, find the middle of those. What would that middle be? So -2, -9 is going to go in the middle of your table. And you're going to fill out the rest using the rest of your table. Let's see. You have -8, -5, and 0. And then it repeats. Regina. It does whatever it says on the table. So it may not do that. Plot all of those points, or as many as you can. How many solutions does this have? Two. And then what are those two? We're going to write them as ordered pairs. So we kind of had an idea as to what those are already because they were given in the table. We could also see them on the graph. So you may see zeros or intercepts written out as ordered pairs or how we were just writing them. Wow. Very good. Okay. So either or. If it says specifically write your solutions as ordered pairs, make sure you're doing that. If it says just write the solutions, it could be both, either or. In your calculator again, let's say you wanted to double check them, you could look at your table, you could also look at the graph. If it looks like it's on there but you're not sure, I would double check it with the table. If you can't find it in the table, you would need to go into second trace, go into the 0, and you can only do this one at a time. I know we've done this before, but let's say I'm trying to make sure this is at -5. Pick something to the left of it, pick something to the right of it, but that doesn't go past this. Hit enter, and it'll tell you what that is. Okay. Let's do one more of these and then we'll move on. Let's do 3. Same thing, put that in your y equals and go to your table. you may have to scroll down to find your repeating y values and where the middle is. What is the middle of that? Yes. So then put that in the middle of your table and fill out the rest. 1, negative, there we go. Negative 6, negative 11. If you want to plot the 11s, you can, but it's going to be off the graph. You don't have to. Once you have that graph, how many solutions does this one have? Doesn't have any. So none. So you can put none, NA, the 0 with a slash through it. What we cannot put is 0, because that would mean there's a 0 at 0, or there's an intercept at 0. Look at numbers once you finish 2 through 6. Are there any others we want to see, do, go over, have questions about? Disregard the discriminant part of the bottom of that page. Do we have any questions on how to determine how many solutions there are on a graph? Or how to find them? If not, find this page. This is the last thing we're going to do together, and then you're going to be working in test now. Okay, so this is like the opposite. We were finding our zeros. Now we're going to be writing the equation. So in order to do that, you have to know what your zeros are. So look at where does it cross the x-axis. I know the numbers are kind of small, but I would write that off to the side, like what those are. So 2 and negative 4. And then you have to know how to write it in factored form. So this would be like, if we factored it, and then we set it equal to 0, solved it, we would get these answers. So if we're working backwards, if we got negative 4, its factored form would be x plus 4. If the answer is 2 and we work backwards, the factored form would be x minus 2. It's usually the opposite of whatever it says. If you're not sure, you could write it out. X plus 4 equals 0. Solve it and see if you get the same answer. If you get the opposite answer, you know you put in the wrong sign. So then to write our equation, we're just going to distribute. X times x would give us what? X squared. And then we have negative 2x, positive 4x, and then combine your like terms. So if I graph the y equals x squared plus 2x minus 8, and I graph the factor form, they should overlap. What question do we have on that? Let's do one more. What are the zeros that are given? What are the solutions that you see on number 2? Which numbers do we see? 7 and 8. So then how would we write those as factor form? So then to write our equation, distribute. So we have x squared minus 8x minus 7x plus 56. Or x squared minus 15x plus 56. Are there any others on this page we want to see, do, go over, have questions about? So for the remainder of class, what I want you to do is first, if you haven't finished 1 through 14 on the test nav, you're doing that. Once you finish that, you're doing 15 through 21, so the next 7. After you do 15 through 21, then you can be working on Khan Academy for this week, Khan Academy Pass. You can be working on the SOL 7Es, 8 and 9, or other test nav practice. Make sure you're using Desmos on the test nav packet. Yes. Anyone have questions on what we're doing for the remainder of class?